Okay, welcome to lesson 4-4. Our goal today is to learn how to compare mixed numbers. We've compared fractions to each other, and we've learned about mixed numbers and how to form mixed numbers, but now we're going to be given two or more and have to tell which one's the bigger one, which one's the smaller one, or how to put them in order. So if you take a look, I'm going to highlight letter A at the top, letter B, letter C, and letter D, and that just means there are 4 situations that could happen when you need to compare mixed numbers. We're going to go over each one independently. So as I work through each example, you're going to take the notes on your note sheet that you have in front of you to put in your binder. Okay, so starting with the first example at the top, example A. The question is, how can you compare two mixed numbers with different whole numbers? So hopefully, and when we're looking at our two examples here, 3 and 2/9, we see the whole number 3, and 5 and 7/8, we see the whole number 5. And I hope this is a very obvious situation that if I have 3 whole and 5 whole items, that it's hands down 5 is the winner. 5 is the bigger whole number, so therefore 5 and 7/8 is the bigger mixed number. So we're going to say that all we have to do is compare whole numbers. And again, that's when our two whole numbers are different in our mixed numbers. We've had a 3 and a 5. They're completely different, so it's very obvious which one is going to be bigger than the other one. Next up is situation B. So this time we're asked, how can you compare two improper fractions? Well, just like our regular fractions, when we go to compare them, we want to find a common denominator. So I want you to write down, the key here is to find a common denominator. When I look at my 9/6 and my 12/8 and I go through the multiples of both 6 and 8, the least common multiple or the least common denominator is going to be 24. So I'm going to put a 24 next to my 6 and a 24 next to my 8. And when I make my equivalent fractions, I see that 6 times 4 is 24, so 9 times 4 is 36. 8 times 3 is 24, so 12 times 3 is 36. And I discover that these two improper fractions are equal to each other, 36/24 and 36/24. So in review so far, in situation A, we have compared two different whole numbers, and in situation B, we've compared two improper fractions. So we're moving on to situation C. How can you compare one mixed number and one improper fraction? So what I'm going to do here is step number 1, because we're going to have 2 steps. I'm going to change the mixed number to an improper fraction. So please write down on your notes, change the mixed number to improper fraction. So when I go over to my 1 and 10/7, I'm going to change that to its improper fraction, 10 times 1 plus 7, and that makes 17/10. But we're still not done because we can't compare 7/5 with 17/10. So step number 2 is after we get that mixed number into an improper fraction, now it's time to find a common denominator. So find common denominator. It's obvious to me that I've got a 5 and a 10, and the least common multiple of both 5 and 10 is 10. So I can easily turn my fifths into tenths by multiplying by 2, and at the top, 7 times 2 turns into 14. So now I'm looking at 14/10 and 17/10, and it becomes obvious that 17/10 is larger, 14/10 is less than 17/10. Okay, last but not least, I've got situation letter D. So the question is, how can you compare two mixed numbers with equal whole numbers? At the top, we had two mixed numbers with different whole numbers, and it was very easy. But down here, if I have a whole number of 3 and another whole number of 3, then it's not very helpful to me to look at the whole numbers. I'm going to look at the fractions, and the first thing I'm going to do, step number 1, is I'm going to compare the fractions only. Compare the fractions only. When I take a look at my fractions, I see that I have 4 sevenths and I have 6 14ths. And that's not easy to compare because they are not in the same denominator, so I can't prove it. So step number 2 for me is to find a common denominator. With denominators of 7 and 14, I think it's pretty obvious that we can change these sevenths into 14ths by multiplying by 2, and therefore 4 times 2 on the top is 8. So I have a new mixed number of 3 and 8 14ths and 3 and 6 14ths. So now it becomes very obvious which of those is the larger, and 3 and 8 14ths is the winner. So 3 and 8 14ths is greater than 3 and 6 14ths.